मोनिका, वेयर आर अदर्स? तुमने बताया था मोनिका?
Yes, ma'am.
कोई आया नहीं? मैंने भी तो
Don't
पोस्ट
know.
किया।
Yes,
क्लास
ma'am.
कैसे कराएंगे बोलो? हाँ, तो फिर ड्रॉप करना पड़ेगा। तुमने इन्फॉर्म किया था मोनिका?
मैम फर्स्ट वाला मैंने मैसेज भेजा था तो फिर
अच्छा, नहीं मैंने तो इसमें ही मैसेज भेजा। एक बार पूछ लो
yes,
तुम अपने ग्रुप में कोई आएगा कि नहीं, वरना मैं क्लास बंद कर दूंगी ना। मैं तुम्हें लेके सिर्फ क्लास नहीं करा सकती, इट्स नॉट पॉसिबल।
मैंने के
अपने
बस
फ्रेंड
कोई मैम कोई रिप्लाई नहीं आता है इसलिए।
रिप्लाई नहीं आता है? ठीक है, 5 मिनट वेट करते हैं, कोई आएगा तो ठीक है, वरना बंद कर देते हैं, क्या करें। तो मुश्किल है
ओके
ना
मैम।
बहुत। अच्छा, ज्योत्सना आ गई है, चलो ठीक है, ज्योत्सना इज देयर, देन आई कैन स्टार्ट द क्लास। ज्योत्सना इज देयर। तुम्हारी क्लास की यही बहुत बड़ी प्रॉब्लम है, बट ही वांट्स टू कम ऑन टाइम, इट्स द इशू। ज्योत्सना, हेलो। हाँ ज्योत्सना, अदर फ्रेंड्स को बोलो, टेल देम टू ज्वाइन फास्ट।
Yes, ma'am.
ओके, छोड़ो, व्हेन यू आर हियर, लेट मी स्टार्ट। कुछ बेसिक्स चीजें आई टेल यू टुडे। अच्छा, फर्स्ट ऑफ ऑल गिव द क्यूआर कोड अटेंडेंस। एक मिनट, क्यूआर कोड विजिबल है? Give the attendance, and today I will start the new module, transducer. Next week exam है, so ज्योत्सना, मोनिका, ठीक है, चलो शुरू करते हैं। लेट्स स्टार्ट। जिसको आना है आएगा। विजिबल है मोनिका? नहीं, एक मिनट, शेयर ही नहीं है। Okay. This is the second, the next module actually, after those spectrum analyzer and all. What is transducer? Mainly what transducer क्या है? Electrical transducer, the classification, selection criteria, basic construction, everything. Okay. Resistance, this is RTD, resistance detector, thermistors, LVDT, strain gauge, everything are very important in this chapter. Now let us come with the transducer part. What is transducer? Transducer is defined as a device which convert one form of energy into other form of energy. So अगर तुमसे कोई पूछे what is the basic definition of a transducer, then what you will say? It is defined as a device which convert one form of energy into other form of energy. Okay. So otherwise, in other way, you can also write a device which converts a physical quantity into the proportional electrical signal is called a transducer. The electrical signal that is producing, that may be voltage, that may be current or frequency, and a transducer uses many effects to produce such conversion. Okay, the process of transforming signal from one to other is called transduction. So ये भी एक new word है, that is called transduction. So if you are asked, you can write that the process of transforming signal from one form to another form is called transduction. So a transducer is also called a pickup, and the transduction element transforms the output of the sensor into an electrical input. So अगर transducer को अगर हमें in a form of block diagram, if we try to show, then it will be like this. Like this means like this. यहाँ पे एक होगा sensing element. Okay. Here will be a sensing element. I'm writing here. It's a sensing element. And next you will be having a sensor over here. And this block will be a transduction element. This block is a transduction element. Okay. And here you will be have a electrical signal. Electrical signal, and here this is the sensor, and this is the response. Okay, and here this is the input, and that is the non-electrical quantity, because I told you it converts one form of energy to other form of energy. This is non-electrical quantity. Okay. So this is actually basically the block diagram of a transducer or transduction element transforms the output of the sensor to an electrical output. So a transducer will have basically two main components. One is sensing element, as I told you, and second is transduction element. Okay, so sensing element is basically what? Sensing element is a physical quantity, or its rate of change is sensed and responded. Or its rate of change is responded to by this part of the transistor. And what is transduction element? It is you can say the output of the sensing element is passed on transduction element. This element is responsible for converting the non-electrical signal into proportional electrical signal. Okay, so these are the two basic definitions of two components. What is one is the sensing element, one is its transduction element. Now, example, if you say under transducer, it comes temperature sensor or temperature transducer, thermocouple, RTD, thermistors, resistive position transducers, displacement transducer, and strain gauge. Not all these elements are there in your syllabus, but some are there. Okay. So next we will move on to, let us see. We will talk about first of all electrical transducers, as you can see here. So here what actually happened? One form of energy will convert into electrical quantity. So here in case of electrical transducer, what is happening? You can see here classification of transducer under that we will do. But first of all, your electrical transducer is one which converts the non-electrical quantity into equivalent electrical quantity. Okay? So non-electrical quantities such as force, displacement, strains, and temperature. So you may be asked in your short question that what are the non-electrical quantities? and electrical quantities such as current and voltage. These are important. So this is a kind of electrical transducer shown here with the help of LVDT. LVDT is also electrical transducer. We will discuss about it later on. Now next is classification of transducer, very important. Okay, and the classification of transducer can be done in many ways. Now some of the criteria for the classification are based on the area of application. Area of application. Now, method of energy conversion, nature of output signal, according to electrical principles are involved here. So, electrical parameter that is used, principle of operation, typical application. Now, transducers can be classified broadly on the basis of first is primary, secondary, then passive, active, analog, digital, and transducers, inverse transducers. Okay. So now we will discuss what are each and every transducers are. So let us come. On the base of transduction, again are of different types: resistive, capacitive, inductive, all those things. Now this is the primary. Before going into primary and all, let me tell you one thing, that a component whose output energy is supplied entirely by the input signal, that is called passive transducer. Actually, passive active are very common word that we use in transducer. So what are passive transducer? A component whose actually broadly one generalization with energy concentration, they are classified under this active and passive transducers. So component whose output energy is supplied entirely by the input signal is commonly called a passive transducer. The active means, in other words, the passive transducers derive the power that is required for transduction from an auxiliary source. So active transducers are those which does not require any, and now I'm talking about active transducer. So active transducer are those whose, you can say that those who does not require any auxiliary power source to produce their output. Okay, those are called active transducer, and they are also sometimes called self-generating type, since they produce their own voltage and current output. Now, some of the passive transducers, if you say, they are come under electrical transducers, and like resistance, capacitance, their parameters are, and the principal operation are being, we will now discuss somehow. Okay, slowly we will discuss about primary and secondary transducers also. But before that, let me tell you, this passive and active is been discussed here also. Primary, secondary, we will discuss later on. See, if transducers derive the power required for transduction from a power source is known as passive transducer. These are examples, LVDT and RVDT. So this is equally important. Okay. And next is, this is continued, and this is for active transducer. You can see here, when there is no need for any source, then this type of transducer are called active transducers. Examples are thermocouple and piezoelectric crystal. Very important, both of them. Okay. Now next we will move on to thermocouple. We will move, but before that we need to discuss about, first of all, resistive transducers. We have capacitive, capacitance transducers. We have inductance transducers also. Okay, so all we will discuss here, but let me tell you some of the examples first. Now, under resistive transducer, let me share. First of all, after this active and passive, let me discuss with you. Number one is resistor. Let me write here only. Number one is resistive transducer. Resistive now, resistance strain gauge is there. Okay, resistance thermometer is there, hygrometer is there, hot wire meter is there, photoconductive cell is there, thermistor is there, potentiometer is there. So all these are the examples of resistive transducer. Next comes capacitance. Capacitance transducer, under that it will come, variable dielectric, dielectric gauge, then capacitance, capacitor, microphone, all these things. Next come inductance. So likewise, we will be having many. What I was discussing with you about primary and secondary transducer. Let me discuss that first, and then we will. This is primary and secondary transducer. Now, here I have given two examples, right? LVT, Burden tube. Now, Burden tube acting as a primary detector that senses the pressure and converts pressure into a displacement to its free end. So, displacement of the free end moves the core of a LVDT, which produces the output voltage. Simply, if you say what is the primary and secondary transducers, so here actually Burden tube act as a primary detector or primary transducer. Okay, primary transducer, and that senses the pressure, covers the pressure displacement with free end. When it comes to displacement, displacement is the parameter which is detected by LVDT. So LVDT is a secondary transducer. Okay. So this becomes the secondary transducer. Clear? So this is one thing. Next, we will move on to thermocouple. Achha, thermocouple, you can see here, there is a picture of thermocouple. The thermocouple, why is so much in use nowadays? Nowadays, in big industries, in very, heavy industries or all those, thermocouple is much used. Why? Because thermocouple is a you can say sensor. Actually, we call thermocouple as a temperature sensor. Okay. So it's a very good temperature sensor. Thermocouple are of many types. So you can see here there are two junction measuring junction, reference junction. A hot, a cold. Okay, a source will be given. It's a voltmeter. So thermocouple more or less we are learning in physics in class 10, 11, 12. So that mechanism is more or less same. Okay. So what you have to learn from here in thermocouple is this table. That from here, what is T type, J type, E type, K type, W type, R type, S type, B type. These are types of thermocouple used and their compositions. It's very, very important. Out of that, K type is more important. Okay. Out of that, K type is more important. So actually sometimes in exam time, questions come like this that what is the composition of J type? J and K, this both are important. What is the composition of J type thermocouple? Okay, like that. Important. So and their range, definitely their range is also important. Now we'll move to piezoelectric crystal. It's nothing but piezoelectric crystal, same in EMI you will get to learn. Out of this, some examples, if you say quartz, Rochelle salt, lithium sulfate, barium sulfate. So this is also type of pressure sensor. Okay, pressure sensor, because crystals are there. If a pressure is being applied, then definitely a spring is there. Okay, देखो यहाँ पे ये है piezoelectric material, ये है mass, ये है spring. Okay, with the help of this mass, you're creating pressure on this material, and definitely some voltage will come up here. So this is also the kind of pressure sensor or primary, you can say. Now come to inverse transducer. In what transducer I told you? Converts one form, a non-electrical quantity into electrical quantity, right? But in this case, but in case of inverse transducer, this type of transducers convert electrical quantity into non-electrical. Example, piezoelectric crystal, analog meter, and voltmeter. Okay, these are important. Here are some selection criteria of transducer, that how you will select a good transducer. First is operating principle, then comes sensitivity, operating range, accuracy, errors, all these things. Okay, stability, everything comes under this selection criteria. Now, basic construction of transducers, definitely I told you, it has two components, sensing element, transduction element. Now, this one is very important, RTD. RTD is called resistance temperature detector. Wait for a second. I'm not having, okay. So RTD is called resistance temperature detector, very, very important. Okay. Here you can see here it just looks like a Wheatstone bridge, right? Having four resistances connected and having a input supply. And you can see here R4, which is this one is the R4. So it is having also a sensitive voltmeter or the galvanometer. That is also important. Okay, so nothing, it's just like thermocouple, is very much sensitive and can measure high, these are all examples of temperature sensor. Thermistor, measurement of precise temperature. Okay, this is again an example of temperature sensor. LVDT. So just now I told you LVDT, displacement sensor, you can say, or you can say somehow it is called displacement sensor because it works only after the displacement of the core. Of the core is the construction you can see here. One excitation voltage will be given, automatically it will start displacing the pole and how it works. So this is all about LVDT. देखो यहाँ पे एक soft iron core है, ध्यान से देखो इस picture को. यहाँ पे एक soft iron core है, इसको एक बार left पे लेके जाओ, right पे लेके जाओ. Okay. Displacement will occur automatically. Output you will get, and you will take it in the middle. Then our equilibrium position is being obtained here. Okay. So the LVDT we have learned a lot. RVDT, I will not go into that. It's not so much important. Next comes strain gauge. It works on the piezoresistive effect. It's important. Okay. So strain gauge important because basics of EMI, you will be having strain gauge. These are used for measurement of stress and strain. If an elastic material is subject to tension, then its resistance changes. Okay. So strain gauge is important. This is the important part. Burden tube, I told you just now, burden tube. This is a burden tube. It's example of primary sensor. Application of burden tube is audio, video equipment, pressure indication, then measurement of displacement, all those things. There are some advantages of burden tube, that is power requirement is very low for controlling the electrical system, and is sometimes used as amplifier to amplify the electrical signal, everything. Disadvantages are there that RTDs, you say, it produces mechanical vibrations, cost is high, thermistor unsuitable for wide temperature, everything. Okay. Acha, conclusion, transducer, because I was discussing about transducer with you. They convert one form of energy into another. That is the important point. And all transducers are very useful in all applications such as microphone, speaker. Actually, transducers, they are used in our day-to-day life. Okay, not so much visible, but we can really feel it. So in this particular chapter, what I was discussing with you, this transducer part, let me tell you one thing about the syllabus. Okay. Dekho, transducer part, more or less I have covered in this module, in this PPT. I have discussed about strain gauges, about resistivity, capacitive load, piezoelectric, everything. Okay, thermistor and all, thermocouple gauges, everything I have discussed. Okay, so in my next class, I will try to discuss and cover the things, the next part of this module. This is module number 4. This is signal converter, that is I to P, P to I converter, temperature to voltage converter, everything. So go through the slides I will share with you, and if you need notes, I will provide you the notes. Don't worry about it. I will upload some notes in LMS portal, okay, on this transducer part. So don't get worried about it. And when this video gets uploaded, go through the video once. Then it will be easier for you to understand. Okay. Thank you so much, Jyotsna and Monica, for attending the class. We will meet in the next class. Okay. You can leave the meeting now.